In this video, we're going to be talking about a VPPM, proportional pressure control valve. It's a VPPM-LK, and the LK stands for IO-Link. The VPPM shown here is what we're going to be using in our example. Our network arrangement is going to be a VPPM connected IO-Link to port X3 on a CPX-AP-I-4IOL, and the 4IOL is going to be communicating across the API network to a CPX-AP-I-EP. That device is going to be connected to the Programmable PLC via EtherNet. It's important to understand that whatever's covered in this video is also applicable to the other line, which is CPX-AP-I-EP and CPX-AP-A-4IOL. So CPX-AP-I and CPX-AP-A are more or less the same, except the footprint and the distribution is slightly different. First thing we're going to do is manage ourselves with the website. And if you don't know anything about the website, I'm just going to copy this. You will go to festo.com. When you log in, you'll have a search. You type in the type code or the part number, and then you say show details. This applies to any device looking for anything. And then at the bottom, we have downloads, software. So for the VPPM, we have IO-Link IDD files. We're going to need this, so we're going to download this. And under expert knowledge, there's nothing applicable in this case. So we'll leave this open. I'm going to duplicate this tab, and we're going to next go to the CPX-AP-I-4IOL. I happen to have a quick link, and again, you would just type in the search window, type in this part number, and under software, we can see that in order to commission this IO-Link Master, you need Festo Automation Suite, alternatively the Festo IO-Link tool, and we also have the firmware. And I'm going to show parts of the Festo Automation Suite, and I'm going to show using the Festo IO-Link tool. There's a small glitch with the Festo Automation Suite plugin for the VPPM, which I'll show, and due to that, we need to use the Festo IO-Link tool in certain circumstances. The next device, well, I'll get to that in one sec. There's also an expert knowledge tab. Okay, the IO-Link Master, if we scroll or we just do a search, Control F for find, we do a search for Rockwell, we will see that there's a application guide for this. We're going to download this, and one more second, I'm just going to duplicate this, and as I said, we're going to go to the CPX-AP-I-EP, and I'm going to just do a quick link to this. So again, in order to commission this device, which is the EtherNet Master, again, the 4IOL is the IO-Link Master, EtherNet interface. In order to commission this, we need Festo Automation Suite and BDS file firmware. Under the expert knowledge, Control F, do a search for Rockwell. We'll see that the same application guide is applicable. And additionally, we have one more, change this to Allen Bradley. So this particular one is also applicable to that device, the EtherNet interface. So we're going to download this guide we're going to download the Rockwell. I'll go back to this. I'll just type in Rockwell. So we're going to download this guide. Save this. Close this. I'll open this again in a PDF editor. So we've downloaded 2 application guides. We'll get to this in a second. Under the IO-Link Master, there's no need to download the same application guide. Under the software, you need to download the Festo Automation Suite, the extension, and the plugin, and the IO-Link tool for this. After you download these tools, you will install the Festo Automation Suite first. Once you have the Festo Automation Suite installed, then we'll go to the extension and plugin installation. Alternatively, or additionally, you need to install the Festo IO-Link tool in this case. Additionally, we need this Festo IO-Link tool, IODD file. So we're going to download this. So what did we just download? Let's go to my download directory. So we downloaded this application guide, and we downloaded 2 zip files. I'm just going to extract the zip files and extract the IODD files, and I'm just going to get rid of the zip files. So now we have this application note, we have add-on instructions, and we have sample demos. We have an IODD file, and we have another application guide. So in both these application guides, there is a wealth of information. I'm not going to cover everything in these guides. I'm just going to get to the point of getting the system working as quick as possible. The next step we need to manage is the mapping of the process data from the CPX-AP-I-EP to the Rockwell environment. The first method we're going to discuss is Festo Automation Suite. When we were at the website, I showed you under the CPX-AP-I-EP or the 4IOL, we had the option to download Festo Automation Suite, the extension and the plugin, and also Festo IO-Link tool. This is on both hardware. So we have previously downloaded the files. We installed the exe for Festo Automation Suite first, and then once we started up Festo Automation Suite, we installed the plugins using the install plugins. And just so we can see what versions we're working with, on the About, I'm using the latest Festo Automation Suite 290719, and under the repositories I have CPX plugin, CPX-AP plugin. This is the 18011, and then under IO-Link device 3 ones, and then extension 29037. There are a couple ways to start a project. First thing we're going to do is scan for devices. So out of the manufacturer's box, you will have probably no IP address, and if you wait a minute, the software will scan and find a MAC ID, and when you click on the device, you can simply go over network settings and assign an IP address. I've done this already. Now we have all this already shown. And we can see that our IO-Link Master has no IODD files installed. So as I said before, the VPPM is installed on port X3, and port X3 is this port 3, and it's not recognizing it. So we have downloaded the IODD files, and the first thing I want to do is install that IODD file. So I'm going to go back to repositories, IO-Link IODDs, and I'm going to say install local file. Navigate to where the IODD file is, and we install it. So now we have this installed. So I'm going to go back to the scan, and I'm going to rescan, and let's see what happens. So now we can see that it was recognized. And at this point, we've installed the file locally, and the next point would be to create a topology. So there are two ways to use Festo Automation Suite to do this. We can simply scan like we have with live hardware, and we can say add to project. And in the process of doing so, this will prompt you. So topology, yes, we want the topology. And it says IODD files are missing. So if we did not put the VPPM in there, then it would install these IODD files for you. Remember, the first two devices are unknown devices. So it's connecting to the internet and then downloading the IODD files that are required. Tells us everything that has been imported. And now we can see that we have an SFAW and an IFM sensor. And if we go now to the home, we can see that it has created the topology for us. So at this point, you would go and navigate through each device and set up parameters. You might modify some things. And we'll notice here that the port mode is deactivated. If I go online, it should reflect what is actually there. It's all at default right now. I'm going to do a read. You can see that we have these different ports that are changed now. So now this part's activated, and the last port's activated. And we can continue to go online with all the other devices to make sure that everything's been updated. Once we have a project complete, everything's set, we can modify some parameters in the devices. Connect to the device. Read from the device. And we can modify whatever we want. I'm going to save this project. Put it in the proper directory that you know about. Go back to the home screen. Reading from the display, saving, and then the last device to go online is the VPPM. And this is where we run into a small problem. The Festo Automation Suite software has a slight bug, and I hope that when you get this video that they have repaired this bug, but Basically this pressure unit, when we go online, this is where we're going to have a problem. I'm going to say read from the device initially, and we see that the pressure unit is completely different, and every time I change it, it goes away. So I'm going to disconnect, modify this, put it at what I want, which is megabar or millibar, and save the project. I'm going to go offline with all the devices. The next step is to do a export. So we click on export, go to Rockwell 5X, L5X, click on the address, and then it creates a L5X export. Export's finished. So now I'm going to show you that we could have built this offline, because we can simply come over on the right hand side here, search for our devices, we can drag them, and we can build our network offline. As well, we can join topologies. You just point and click, and you're doing this. So you can build everything offline just like we did, but we, for the sake of time, we're just showing this as a scan. So we've exported the L5X of the topology, and we're going to use Rockwell to import that. The next step I want to show you is the web server. So if we go into the web server, let's say that we weren't there, we simply type in the known IP address. Now we arrive at the web server, and with the web server we want to modify parameters, and the parameters, if you click on the devices, are all embedded underneath the headings. And if you are trying to modify this, of course you have to not be connected to a PLC. In this case, because I was doing some sampling, my PLC is still connected to the device. And anytime you want to make a change to the devices, you need a password. The username is admin, and the password is on the side of the CPX-AP-I. It's the product code. So I'm going to sign in. You get the green parameter right, success. Now you've entered it all the time. Now you can change it anytime. You will not get prompted again. So let's say that you've made all your parameter changes and you're ready to take the snapshot, because that's basically what you're doing with this L5X export, is you're taking a snapshot of all the parameters, and those parameters will be stored in the PLC. So anytime there's a new connection, the parameters will be downloaded to the device. So let's go to Rockwell L5X export project, and I'm going to leave everything as default, submit, and then download. And the web server blocks it. Well, I'm going to keep it, and then I'm going to open the folder, making sure I know where this is. Copy. The next step is going to be in the Rockwell environment. So put these files somewhere where we can access them later. So now we're going to deal with the Rockwell. And like I said, I have placed the two individual files, which are the exports, into two different directories. We're going to look at both of them, and we'll see that because our Festo Automation Suite project was called VPPM, that it put that first and then the _EP. Whereas with the web server, it's only using the name that we assigned in the web server itself. So it's only using this name. I have L5X associated with the Rockwell software, so if I double click on this, it's going to open a Rockwell project and then start to prompt us for import features. So it's going to say, where do you want to put the file name? It's retained the same name as the L5X name. And of course, we're going to pick a version of software. These are the versions that I have installed. Yours might look different. And in my case, I'm going to use 32 because my PLC has version 32 firmware in it. And then I'm going to say import. And we wait for Rockwell to convert the L5X to an ACD project file. ACD meaning the extension on the file name. So let's look at what we've done here. So what the export in Festo Automation Suite did was it created this generic module, which is pre-configured with the IP address and everything, the name, and the instance sizes and so forth. It's connected over unicast with a 10 millisecond RPI. If we go to our main program and go to the main routine, we'll see here that there are some mappings. And we can see that there are some data types. So if I right click and go to monitor, you can see that there are, if you go to edit tags, so these were created tags, and this is the raw data. So this EP80 or 95 is the raw data tags for this Ethernet module that was created, and the program is mapping the raw data to the data types. And the data types, if we go back to the data types and we expand those, because those are used to define data types, they're very different inside. And under assets, user defined, we open up some of these structures, we'll see that there are a bunch of work that's been done by the software to reduce the amount of commissioning time. And on that note, we're going to now do the exact same thing with the L5 export that was created from the web server. So let's navigate back to the place where we stored the files, web server, and we're going to double click this just like we did the other one, and it will open it within RS5000. If you don't know how to associate the file, then you can simply open a new project and you would select import or open, pick the L5X file and continue. So it's opened the file, and again we have the same generic module. So let's look at the other project side by side. So I have both projects side by side. Everything here looks exactly the same. And the thing I want to point out is the data types are different. The right hand side is the PLC export from the web server. It has this extra bit. On the left, we don't have the bit, but the mapping itself looks identical. The problem is that the tags are different structures. See how the data type structures are very different? This is being shown so that you have an understanding that Festo Automation Suite is a little bit behind with the software L5X export. The web server is more up to date. So the web server has different data type structures, and if you're going to start the project using offline files in Festo Automation Suite, it's important to understand that moving forward, if you're going to start using the web server to do an export it's going to be a very different structure. So it's important to start on one and finish and continue to use the same platform. Festo Automation Suite will be updated in the future. So I'm going to close the VPPM from the Festo Automation Suite, and I'm going to now start a project with a PLC in it. So this is my PLC project. So this is your project, and you want to get the new information into the project. We would simply come over, copy this Ethernet module, come over to the Ethernet, Control V or right paste, right click. You could also do a paste. Now that we've done this, I'm going to pick a default name. Now in this project, I'm going to import the file, add, import, pick the same routine, let it overwrite, pick the defaults, overwrite defaults, click OK. One warning, name collision. Close this, go to the controller tags. We have the same inputs output status, and in the main routine we have exactly what we had in the other program. So now I can go over to this and close the project. I'm going to try to do a download to make sure that this step is complete and working. So in the newer software, we have this Who Active. Click on Ethernet, find your PLC device, and my PLC device is this one. I'm going to say Set Path Project. Now that we've set the path project, we can use this drop down, and I'm simply going to do a download. Continue. Confirm that the Ethernet module is connected, running, and everything seems to be okay. So now we can go into our map outputs, for example, and we could force some things on. We could come through here and just force a couple inputs and outputs, or outputs, and we would know that everything's working. So I'm going to save, go offline. A quick overview and summary of what we've done so far is we have downloaded application guides from the website. We have opened Festo Automation Suite, and we have exported the L5X and imported that into Rockwell environment. We have done the same thing with the Webserver. We've exported the L5X and imported that into the Rockwell environment. The next step is, as always, to get the process data. And in order to understand the process data, we need to first go to the website and download the user manual for the VPPM. So if we go to the website, we click on user documentation. Under the VPPM, you'll see the VPPM-LK. Download this. I'm going to save this to the same directory as previous documents. Now we have this document open. If I scroll to the second page, I think, we zoom in a little bit, we'll first see that the input and output word are 16-bit, set point and actual. If we scroll a little further, we can see that we have a section called process data. And again, it discusses pressure actual value and pressure set point. It's important to understand that the process data output is the value that is being sent from the PLC to the VPPM. Pressure data input is the value coming from the VPPM to the PLC. And it's also a necessity to understand that an IO-Link Master uses a Motorola CPU, which is big endian, which has the high order byte at the start address. And because the 4IOL is transferring the data to the CPX-AP-I-EP, which is connected to the Allen Bradley. The Allen Bradley uses an Intel Atom CPU, which is little endian. So in order to look at the data properly in the PLC, we need to do a byte swap with the Allen Bradley PLC. If we go to the PLC program, we can add a routine for the process data. And we go to new routine. I'm going to paste in a name that I've already assigned because we're using channel 3, which is the VPPM-LK, and then this is going to be the process data. The next step is to understand where the process data is arriving and being sent from the controller tags. So if we open up the controller tags, we can go to the inputs and outputs, and the first thing we'll notice is that the module 3 for IOL under inputs and port 3 process data is starting right here. And if we go to the outputs, module 3, because it's the 4IOL, port 3, then we have this. So we go back to the process data routine, and we're going to add some code. And we need to do a swap byte. So if we go to the move logical data, we can see that there's a swap byte feature in this newer Rockwell software. We're going to grab that and drop it onto the rung, and we're going to assign this set point a new name. And as we said, it's 16 bits, so it's going to be an integer. And we're going to do a reverse order mode. And we need a temporary tag before sending it out. Pressure set point swap. Again, another integer. Then we need a copy command. There's a copy synchronous. We can drag this to there, and then we need to find our output data. So we've already said that this is the output data. So I'm going to copy this, paste it, and we're going to do a length of 1, and it'll take care of the rest. So this is what we're going to use to set our output. We're going to add another rung because we need feedback from the output word. While we're talking about input and output word, I'll just right click and add a rung comment. So this is the pressure set point. They call it input word in the user manual. And the next rung we're going to be doing is output word, pressure actual. In order to read this properly, we need a bit field distribute. I come over for bit distribute. I'm going to add 2. We need a destination word, which is going to be our resulting feedback. So I'm going to call this the actual millibar. Again, I'm going to give this a integer format because it's a 16-bit word, and drag this to the destination. And now we need to look at the raw data. The raw data coming back are the inputs on these 2 bytes. So this is the first byte. I'm going to put this on the right. Copy this on the left. Source bit is going to be 0 on both, and the destination bit is going to be 0, 8 bits long. This bit over here is going to be the higher bit, due to the swap. So we're basically swapping. We're going to put the low byte into the high byte area and the high byte into the low byte area. And in order to have this scan properly, we need to, of course, add some code. We're going to add a rung, JSR, and we're going to select that routine that we just created. And while we're here, I like to have my inputs and output mapping in routine, so I'm just going to add a routine, call it map inputs, and I'll also do a map outputs, so I will add another routine, and go back to the main routine, and I'm going to take my inputs, cut, paste, delete this rung, and I'm going to cut, paste. I like to scan my inputs and map my outputs so that control the data flow so that there's no changing of input data or output data during the scan. This main routine I like to use just for having the jump subroutines. I'm just going to put this so the map inputs are there and my map outputs are always the last in the scan, so we can control the scan this way. Save the data. And before we do a download, I need to change this length to the number 2 because we're transferring 2 bytes of information, so the length is based upon the destination. And if we do a download now, we can modify this to 1000 millibar, and we have a response or an actual value coming back at 1000. If we want to go to Festo Automation Suite and confirm this, we can go to the device and we can connect, read from the device. Again, the millibar will keep coming up as a problem, but we can ignore that for a minute. We can go to process data, and we can see that our input and our output are the same. If I modify the value to 5000 or 5 bar and go back to the Festo Automation Suite, there's our set point value and there's our actual value coming back. So we can disconnect. I have to keep changing this back so that we don't have the problem while we're offline, and go back to the code, and I can put this back to 0, and we can move on to our next feature of the VPPM. We're going to go offline. The next feature we're going to discuss is status of the hardware, so and the devices. So the first thing that we want to have an understanding about is whether our Ethernet module has a connection to it or not. I'm going to add a routine, give it a name, because we're going to be looking at CPX-AP IP address 95. We're going to add a get system value, which is a Rockwell feature, and I believe that is under input, this one or this one. Where is it? Right here. So get system value, and we're going to have module. Instance name is going to be the module of this module right here. Attribute name is going to be fault code, and the destination is going to be this tag. So what I've done prior to this is I have imported my own data types, and I have as well added a tag called PLC of that data type. So I have a structure. I have a lot of different things in here, my standard structure. So You can look at the sample code when you're looking at all this. Now that we have the fault code, which is a dint, then we're going to copy and paste, and we're going to add another module 95, and we're going to have the entry status, and we're going to have entry status, same array number, and then we're going to add a bit field distribute. There it is. We're going to take the entry status. We're going to look at specific bits. We're going to look at bit 12. And we're going to look at entry state 16. And destination, we're going to do destination bit is going to be 0. And we're going to look at a length of 4 bits. And then we're going to look at a compare. So we're looking at the fault code. It's equal to 0. And we're going to zoom out a little bit. And we're going to do another equal. And we're going to do the entry state. We're going to select 4. We want to know if it's running or not. And then add an output. And PLC OK. So basically we're going to look at the module fault code, the entry status, and we're going to compare these to make sure that we have no faults and we are running. And when that's true, then we have the PLC module OK. The next status we're going to look at is going to be the quality bits for the IO-Link Master. And for this we're going to add another routine. Call this channel 3 VPPM-LK PQI. And let's go to the controller tags for a second. So when we're looking at our inputs for the 4IOL, we have ports 0 through 3. The quality information are coming through on these right here. They happen to be called port 4, 5, 6, 7, but it's actually port 4 is equal to port 0, 5 is equal to 1, 6, 2, 3, 7. So we have these bits. If you look at the IO-Link specification, in this case we have to label the status bits ourselves. So port 0 is not used, not used, and then we have port. So we have bits 5, 6, and 7 are the important bits in my perspective. We've got the device communication, device detected in pre-operate or operate. We've got a device error, port error, and we've got port qualified process data valid. And if we go back to PQI, then we can take this bit, because we want to make sure that we're communicating to the EtherNet IP module, and we're going to add this bit. Then we're going to look at 2 bits. Go back to the controller tags. And we're going to look at 5 and 7. In this case, I'm going to create a tag called devices connected. We're going to add another rung and a branch, and we're going to copy this bit, copy this bit, change it to 6. Actually, I'll get rid of this branch, and we're going to say device error. Now that we have these 2 routines, then we have to scan them. So I'm going to copy paste, put them in order. So we're looking at this, copy paste, PQI, save. Let's do a download now. And close this. And we can see here that we have module connection okay. If I actually disconnect the Ethernet cable, then the module okay goes away. Reconnect it. Give it a second for the connection to take place. It's back up and running. If we go to our IO-Link Master, port qualifier information, and I actually disconnect the cable for the VPPM. Now it's disconnected. Do I have a device error? And I'll plug it back in. It's pretty quick to recover. So now we have status of the devices, and then we can move on to our next feature. Let's go offline, or save it, and then go offline. The next feature we're going to discuss is diagnostics for the VPPM. If we go back to the user manual, in the user manual we have error numbers. 5100 for under voltage, ACA1, ACA2, these are hex numbers, and then it continues in the top right of this page, AC42, 6320. So these are the error numbers, and we want to get this error information into the actual PLC. So we can trigger faults on the HMI. And in the PLC, if we go back to the map inputs, we have the status word. So if we go to monitor, let me just zoom in a little bit. So status, go to monitor, and we can see that we have an overview of status, active, and diagnostics code, and we know that module 3 is our IO-Link Master. So we're going to use these tags to get the information. Festo has a document called AP_diagnosis, and what I've done is I've taken that document and I've extracted the correlation between the codes that come through on diagnosis code, and this converts to the hex number. So we need to convert from the hex number to these codes, because these codes are going to be coming through automatically. So what I will do is add a routine, new routine, call it diagnosis or diagnostics. And for sake of speeding up time on this video, I'm going to paste some tags that I've already created. So I'm adding the event code that we just observed in the manual. So AC42 6320, C42 6320. Now we're going to add some code. So we open up the diagnostics routine. I'm just going to close all the other, and we're going to add a equal. It's hard to see these. We go back to the controller tags, go to the status, copy this diagnosis code, go back to the routine. We want to compare this, and I'm going to copy paste this equal again, or add another equal. I'm going to pick channel, make sure we're on channel 3, and we keep adding some code. We want to add a output bit, and we're going to add this tag, event code 10. It's equal to 080A01A9 from the AP diagnosis And I'll add run comments to the sample code concerning all this, and I'm simply going to copy the entire run and paste, and we're going to change this to ACA1, and we're going to change this ACA1. This one here is going to reference this hex ID. And to change this hex code to that value, then I'm going to continue to populate this. Stop the video for a second and I'll populate this and add some run comments. Okay, so I have added some run comments and the rest of the codes. And the last thing we need to do is add a jump subroutine. Copy paste and diagnosis. So let's compile, everything's good, and let's do a download. Okay, let's just back out a little bit with the view, and let's pull the sensor off. So I've pulled the sensor off, and we have the diagnosis code coming through, and again we would of course have the PQI status as well, saying we have a device error. Connect it back up. And the next one is pressure set point. I won't use that yet. Let's find something. Okay, how about the voltage? So I'm going to force a low voltage. And now we have a low voltage. And I'll connect the voltage property back up. So all of these faults are coming through, and now we have a very basic project for the VPPM. We have process data, port qualifier information, we have status of the CPX-AP-I-EP, we have diagnosis of the VPPM. Save the project, and let's go offline. And we're going to show one last point, because the fact that the Festo Automation Suite has this problem with this pressure unit, as I showed earlier, where you change something and it goes back when you're online. Due to the fact that this has an issue, I'm going to show you the Festo I-Link tool. So I'm just going to go back offline, put this back to default. If we go back to the website, I had shown you under the 4IOL software tab, in addition to the Festo Automation Suite, we have the Festo I-Link tool. So I have downloaded this and I've installed this onto my computer. If we go to the desktop, then we can see the Festo I-Link tool. I'm going to start this up. This is the version number. I'm assuming you would have had to install it with admin rights. This is the old tool before Festo Automation Suite encompassed this product within it. Takes a while to start up. Just as we did with the Festo Automation Suite, we have to also install the IODD files. So we have import IODD files. We can select the directory where we've unzipped the IODD file, and then we say import. I'm not going to do this because I've done this already. Under the master, we have the different head modules, the CPX-AP-A-EP and the CPX-AP-I-EP. We can also do a search. So the idea here is that we're going to search for the EthIP master, and we will tunnel from the master to the 4IOL IO-Link Master. So I'm just going to expand this. I'm going to do a search. I was hoping this wasn't going to show up. I'm going to show both methods in case we have a little conflict. So I'm going to say forget that. Then I'm going to drag, click and drag up and then we can select the IP address we want of the device, and it says that it's found, so now we can connect to it. I'm going to cancel that. I'm going to delete this and do a search and do it the other way. So I'm just going to double click this. So those are the two methods to get in. The IP address is here. Now we're going to go online and we're going to read from the master. So we're reading from the master. Now the next step is to do a check for device. So we're going to scan for devices. And we see here, because we have registered our IODD files, that we have these particular devices connected to our ports. In our case, we're concerned about the VPPM, and I'm going to take the devices over into engineering. So now the device is here, and I'm going to double click the device. This opens another window. So we're actually online. We can select this to go offline, and we can see the process data. If I go back online with our PLC, go back to our process data, sorry, wrong one, process data, and I change the requested pressure to 1000 bar, or 1000 millibar, I mean. We'll see that we have no feedback right now. Let's go see the IO-Link tool. We have pressure set point set at 1000. When I apply the pressure now at the valve, now we have a feedback, and we have a feedback in our PLC as well. We can continue to go. We do an upload from device, and over here the green means that we are synchronized. Go to the observation, parameters, and this is where we can modify our pressure to our pressure unit to PSI or millibar, and once we're done this, we do a write, and we change the whole dynamic of everything. So now that's been changed. So I'm going to put this back, do a write, and we can modify other parameters. This is the tool that you need to use for the VPPM, and we can also send some commands. You can send a system command. I think it's 80 is the reset the factory. Maybe I'm wrong. It's actually 82. So if I do a write, so it sends a write, and when we go back to the parameters and do another upload, we've reset everything to factory defaults. So this is a summary of the Festo IO-Link tool. This is the last step in this video. I hope this helps. Look below the video and you will find some sample code links